Okay, here's the last review video. I say last, although I am going to upload an implicit differentiation, some more help with the implicit differentiation, at least one and possibly two videos for that. But let's get to this problem here. We're maximizing revenue, and in this question, we're going to use these equations right here. And these will be given to you on the last page of the exam. It'll look just like this. You could actually tear it off if you want to, have it side by side with your test. But these are the equations that we will use, and your first step in answering this question is to decide which of these you actually need. Well, we are maximizing revenue, and so that means we're going to need the revenue function. I can tell you right now we won't need the cost and we won't need the profit function. We'll just need the revenue, and if we need the revenue in order to derive it, in order to construct it, we're going to need the price function and the quantity function. Well, here's the quantity function right here, and so our only decision left is to decide which of these two price functions we're going to use. And that's why I've put in bold decreases or increases. Well, if we look at the question, it says for every 1/10 of a pound reduction in price. That's what that symbol is. It's a British pounds. Probably be dollars on the test, but I was having a little fun. Put in an international question. So, but it says for every 1/10 of a pound reduction. Well, that's a price decrease. So now we have decided which of these three functions, which of these three equations we need. We need this price equation, this quantity equation, and this revenue equation or function. So in order to answer the question, all we have to do is read the story and decide how to fill in each of these blanks. Well, it says that they sell 1,200 of these sandwiches at a certain price, at a price of $4.50. Well, that's how many they sell right now, and so that's the original quantity. The price that they charge right now is $4.50, and so that's the original price. So then you just need to fill in price change and number of price changes and additional units sold and number of price changes. Well, the number of price changes is what we're looking for, and that's going to be the number, that's going to be X. I've bolded and highlighted it here. That's going to be the number of 1/10 of a pound price reductions. We let that be X, and so in our equation, or in our function, number of price changes just means X. And it'll be that way on the exam too. It just means X. So what we need to determine now is the price change, what is that going to be, and the additional units sold. And so it says that the price change is 0.1, and so we plug that in right here. Original price 4.5, price changed negative 0.1, and how many price changes? X. That's the the number of price changes we're going to make. And then for quantity, the original quantity is 1,200. How many are we going to gain by making this price reduction? Well, it says that they'll sell 30 more sandwiches if we reduce the price however many tenths of a pound. And so that's the additional units right here times X. Now you have a price and a quantity, and you need to multiply those two together to get the revenue function. Price function, quantity function, multiply those two together to get the revenue function, and that's shown down here in our table of functions. And so I've placed those two, the price and quantity function, here, and when you multiply them out, you will get the revenue function, in this case negative 3x squared plus 15x plus 5400, and that's what we need to maximize. Well, to maximize it, once again, we find the derivative, and the derivative is just using the power function, negative 6x plus 15. Again, this is a linear equation, so it's very easy to solve when setting equal to 0. Set that equal to 0, add 6x to both sides, divide both sides by 6, and you have x equals 5/2 or x equals 2.5 as your critical number. Excuse me. So, to determine what price we need to charge, we go back to our price function, 4.5 minus 0.1 times whatever x is. We just determined x is 2.5. And when we do that arithmetic, we come up with 4.25, 4.25. Now, to find what revenue that's going to yield, we substitute 2.5 into the revenue function, and that's negative 3 times 2.5 squared plus 15 times 2.5 plus 5400. And that comes out to 5,400 or 5,418 pounds and 75. Gee, I don't think it's 75 cents, but it's 0.75 pounds. So that's the amount of our revenue, and that's the amount, or that's the price, and that's the amount of the revenue. Now, when you get to this 2.5, again, that's the number of price reductions. That's not how many sandwiches you're going to sell. This quantity is, this value of x is the number of price reductions, and that's how all of these functions are set up. X is a number of price reductions. So, the summary here says with 2.5 price reductions of 1/10 of a pound, a price of it says dollars. Well, I shouldn't say dollars. So a price of 4.25 pounds will result in the sale of 1,275 sandwiches per month and maximize revenue at 5,418.25 pounds. Now, the last question is an implicit differentiation, and I will put this in the simplest terms because I know we just learned it and it's a bit to absorb. But your relation will be given in the form of an equation, and what you want to find is y prime, basically. You're going to find y prime, which is dy dx. It's the rate at which y changes with respect to x. And so to do this, we differentiate every term in the equation with respect to x. Well, here's x squared. How does that differentiate? Let's just use the power rule. That gives us 2x. Now, how do we differentiate y with respect to x? There's no x's in there. Well, we are thinking of that as a function of x. And so if this is f of x, what's its derivative? We don't know specifically. We just have to refer to it in the abstract as f prime of x. And just to keep our notation neat, or easier to write, instead of writing f of x or f prime of x, I write y, and then this derivative is y prime. And so on the right side of the equation, we have 4 times e to the y. Well, the 4 remains when we differentiate, but what is the derivative of e to the y? Well, when you have terms that have a y in them, Just differentiate them as if they were in terms of x, and then put a y prime at the end. The derivative of e to the y is e to the y, but we're using the chain rule, and so we put that y prime on at the end. So now we have an equation, 2x minus y prime equals 4e to the y prime, and what we need to do is solve for y prime, or isolate the y prime. And so what we do on the right side is, well, first we add y prime to both sides, and we factor the y prime out of these two terms. And so we have 2x is equal to y prime times the quantity 1 plus 4 times e to the y. Then we divide both sides of the equation by 1 plus 4 times e to the y, and that gives us our y prime. That is dy dx. That is the rate at which the y values change with respect to x, or the function values, if you prefer, even though it's not a function, with respect to x. Okay, that's everything. That's all the review questions for exam 2, and I'll be posting a video that shows us a few more examples of implicit differentiation here a little bit later.